Hello, everyone. Thanks for attending this section. My name is Adriana Bean. I'm the sales manager for Americas with Qua Group. As part of our Qua Care program, we are starting now our webinar series dedicated for this region. So the idea here is to spread out our technologies and applications and find opportunities to collaborate with you, as we are sure that we can add a lot of value to your projects and developments. Today, we are going to talk about our fractional electrodeiyonizator to understand a little bit more, not only about the technologies, but important operating parameters, sizing, and some of the applications and reference that we have. We estimate the presentation in about 45 minutes. We are going to leave the final minutes for Q&A. So you can now drop your question and comments in the Q&A section or in the chat. And then we are going to try to answer your questions as much as we can. We also have our Global Technical Sales, Abhijit Puranik, joining, and our marketing director, Kamakshi Sharma. They both have extensive experience with Qua products and will be joining whenever is required. Actually, there are a lot of people joining here. So I think I'm gonna wait just a few minutes. We can start like 11:05, just to everyone be able to attend here. Okay, some people doesn't have the Teams account, but I think they are able to see the presentation and to ask questions in the chat, right? Let me start sharing the presentation here. Kamakshi, you can hear me well?
Yes, everything's good.
Just to make sure.
We can get started.
Okay. Okay, thanks everyone for attending this section again. As I said, we're gonna be presenting our fractional electrodeionization for high purity water. It's a pleasure for me to introduce you to our technology. This is the agenda for today. A little introduction to Qua, our structure, our team. Introduction to electrodeionization, the technology. We're going to talk about what sets Qua FEDI apart from EDI conventional technology. We are going to take a look inside and outside at FED stack. We also will take a moment to talk about operation, cleaning, and sizing program, and also mention some references we have in this region and in all over the world. And in the end of the presentation, I'm going to open for Q&A sections. Again, for the ones that are joining right now, I want you to drop your questions in the Q&A section or the chat. Then in the end of the presentation, we're going to try to answer as much as we can. So who we are? Qua is an innovator of advanced membrane technologies. We have been around for over 12 years now. And each membrane product was designed to add a high value proposition to our customers. So you can see we have over 500 installations all over the world. we have treating more than over 450 billion of liters of water daily. And also we have clients in over 30 countries right now. Million, sorry. So we provide our customers with a very, very wide portfolio of membrane products. Our product line consists in QSAP. The QSAP, actually FEDI is the one that we are going to talk about today, the fractional electrodeionization. QSAP is our hollow fiber membrane, ultrafiltration membrane line. In this product line, we have PES and PVDF membranes, and we have also a new launch, which we call Q-Connect, that has 100 square meter area membrane. We have the CeraQ ceramic membranes, the tubular technology that we can work with different pore size, since nano, micro, and ultrafiltration ranges. And we also have the NVQ membrane and BR with flat sheet membranes, and we are having new launchings soon. So a little introduction to the EDI technology. Electrodeionization is actually an electrochemical process that combines ion exchange, ion selective membranes, and electrical current in just one product in order to remove ionized and ionizable species. It is applied as a polisher for RO to produce high purity water with less than 0.1 microsiemens of conductivity. And it's been largely used to replace mixed bed mixed bed ion exchange. This is one of the main use we have seen here. So how it works, how the water flows in a typical EDI stack. As you can see here in this scheme, the water flows from the bottom to the top. The feed water is actually split in 3 streams. One goes to the electrode rings, the other one goes to the concentrate chamber, and the other one goes to the dilute chamber that we call, this is actually where occurs the ion exchange. So this is where we have the ion exchange resins actually. So this is the electrodeionization process itself. If you can see here, this is how the pair works. The EDI cells are comprised of titanium electrode, anion and cation selective membranes, those ones in green and orange here. And in between, we have the resin, the ion exchange resin, charged with H+ and OH-. When the water comes from RO, as I explained before, the stream gets divided into 3 parts. Once the water enters the chamber, the DC voltage is on. And then it starts the dissociation of the ions here. Those ions are attracted by the opposite charge of the electrodes and flows into this direction. I mean, the positive ions here, for example, will move towards to the right. And it meets the cation. When it meets the cationic membrane, it allows those ions to move forward. But when it meets the anion membranes, it's not going to allow it to move forward. So what I mean here is that the ions get stuck in this chamber, and then they are rejected. The similar process occurs in the left side, where the negative ions start moving forward to the positive electrode rings. right? Electrode. And same process occurs here. In the resin bed, the ion exchange process takes place. And then you get one of the most pure water in the world. Definitely, the main advantage we see when we compare, as I mentioned, this is one of the main applications to replace the mixed bed. When you compare mixed bed with ADI, we can see the main advantage here is no regeneration chemicals, right? So when you have regeneration chemicals, you need, first of all, the transportation of those chemicals, right? Then you're gonna have you have to storage these in your site. Then you have the regeneration itself, the process. Then you have acid and caustic neutralization. You have to treat those waste generated. And all of those processes, in the end of the day, it's a lot of cost involved, right? It has a lot of cost involved. So no storage or handling of toxic chemicals and very safe operation are the main advantages when you compare with the mixed bed. Another huge difference in terms of the consistent product. The mixed bed processing has the batch, needs the batch, right, to regenerate the membranes, the resins. It happens sometimes on a daily basis or maybe every 2 days, and it's very, very costly. So in the EDI, we have very continuous processing. So we can actually avoid the operator intervention is not required. The installation and commissioning time is much lower. Without saying that it's much easier to operate. It delivers very consistent water quality for the treated water. To sum up the advantages, we can mention that EDI has much lower operation cost. Automated operation also reduce the operator intervention. And also it's a modular equipment, very easy to scale. And when you compare to the mixed bed, you have a lot of civil works here. And it's a much smaller footprint. You can make it mobile. It's a trend actually to make it mobile. What sets FEDI apart from EDI? So our FEDI modules attend the most high quality requirements. They have CE certification, UL certification, and also our manufacturing facility is ISO certified. We also have 3 patents for this product. The first one is related to the dual voltage process, which is a unique technology of QAM. The second one is related to the composite ion exchange media, which improve the utilization of the membrane area. And the third one is related to the high flow rate module that was designed for double pass arrow. I'm going to explain a little bit more in the next slides what each one of those patents means. So here, what differentiates FEDI from conventional EDI? To make it clear, this is a side-to-side comparison. In the left side, you have the conventional EDI cell that runs usually with high current since the beginning of the process. What's the problem solved? The high current promote more effective dissociation of the H plus and OH minus. The hydroxyl ion is one of the main responsible for forming the scaling, actually. And if there are carbonates and high hardness present in this water, eventually you're going to have calcium carbonate precipitating. And these will be deposited in the membrane surface here. After some period of time, those stacks will require a larger current. And also, we will require cleaning and regeneration procedures. Those procedures will ultimately increase the operational costs, right? And also the lifespan of the stacks. So QA, especially to overcome this issue, QA has developed this innovation process that we call fractional electrodeionization. And we actually kept the same basic technology of EDI, but we separate the process into in two stages, which makes the whole difference here. Okay, to explain it a little bit better, we divided in two zones, right? So this is the hardness removal zone. The first, when the water first when the water first entered the FEDI, it meets this hardness zone, which has a low electrical driving force, and a strongly ionized impurities are removed here. The reject is going to have a pH acid, which helps in eliminating scaling. And also, it prepares weakly ionized impurities for the stage 2 removal. So instead of giving the high voltage in the beginning, we supply low current, which is good enough to remove the hardness, but limitate the split of the water, the H plus and OH minus formation. So we minimize significantly the scaling potential here. So this is the first zone. The second zone we call silica removal zone. In this stage, we apply high current and will be very, very effective to split the water in H plus and OH minus. And also, you don't have hardness in this zone, right? Because it's going to be removed here in this first rejection. That's why, that's the reason our FEDI can handle up to 3 ppm of hardness in the feed water compared to 1 ppm to the conventional EDI. In this zone, actually, we're going to have very efficient removal of silica, boron, and CO2 that we call weakly ionized impurities. So the differentiations of the two-stage separation. In addition to that, we have two distinct voltage and pH operating zones, as I mentioned. We have the working zone that takes primary load. We can say that 90% of the removal occurs in the first zone. Regenerated zone for polishing mode, it creates ideal conditions for silica removal at high pH and high removal of ionic TOC. And we can optimize the power consumption here. So we have low voltage for primary load, higher voltage for the second, and better control for the process. I would like to highlight that in addition to that, the silica removal would be more efficient in the second stage, but we also can create like a buffer for the second stage. So in case that we have fluctuation in the feed water ion load, we can take this water easily treated. Those are the main products that we have for the different requirements. So due our wide range of products, we are able to choose what's the optimal product according to your specific application, not only in terms of quality, but also the most effective, rather than try to fit the product to your application, right? So we have the DV module for high hardness. We have the SV module for lower hardness application. We have the HF for high flow application, which was designed especially for double pass RO. We have the RX modules for pharmaceutical applications. And we also have, actually we are launching right now, and I'm giving you a spoiler, but we are launching in the next probably 2 months, the FEDI Giga, which has much higher flow rates. I'm gonna explain a little bit more further. Okay, here we have summarized the main advantages that you can observe in our FEDI stack, on our FEDI technology. The two-stage separation provides greater flexibility in the feed water. The high hardness tolerance also reduce the scaling. It's probably one of the highest hardness tolerance in the industry. The optimal power usage leads to improved efficiency as well, as we don't need any chemical during the operation. This means a clean, green, and safe technology. And we also provide very, very good quality product, which makes FEDI an extremely robust technology and leads no longer lifespan, which is proven in most of our facilities. We're going to show you some references. Okay, in terms of value proposition, this is really important to understand. So the patented dual voltage was designed to handle upset water with very consistent water quality. The hardness tolerance, in the end of the day, it means lower CAPEX and lower OPEX, since in most of the case, we can prevent the double pass room, right? And also the frequency of chemicals will be much less. Flexibility to handle feed water quality fluctuations. Since we have the second stage, we create kind of a buffer, as I explained before, so we can handle variations in the feed water loads. We have very quick startup. It delivers target quality very, very quick. So this is because of our manufacturing process, because of our media patent, the composites that we make with the media. It takes much less time to achieve the product quality. And this is a very important advantage here. We have vertically integrated manufacturing. I had the honor to visit our manufacturing facility recently, and I could see how they carefully manufacture the major components internally, assuring quality and reduced costs. And also the hot water sanitization for the RX modules, the pharma modules, we can take over 150 cycles of hot water sanitization. Talking about the applications for FEDI. So in the power industry, I think is one of the main applications here. The main concern is silica, which could represent a real nightmare in the pressure boiler systems. Also considering they have closed loop systems, so the specifications are usually less than 0.1 microsiemens for conductivity. Reactive silica less than 10 ppb, sodium less than 5 ppb, and chloride less than 3 ppb. For pharmaceutical industry, not only the high purity water specification, but it's important to mention the process of validation and documentation, which is very complex. And using EDI, you can do it only once when compared with the mixed bed. So it's very welcome in the pharmaceutical industry. The semiconductor and microelectronic industries is one of the most stringent water specification in the industry, I would say. And usually it requires a 16 mega ohm resistivity, or even better than that. We also have many applications for industrial water. For example, I would say food and beverage, chemical, steel manufacturing. Also, it's a hot topic right now is hydrogen generation, where usually they require around 0.06 microsiemens of conductivity, and silica less than 5 ppb in the treated water. We also have opportunities to replace actually the existing mixed bed polisher. This is another application to replace other EDI based with FEDI, and also condensate polishing. The inside and outside look of FEDI stack. So here you can observe, this is the port, this is the front view in the right side, the front view of the stack. As you can see, here is the power supply, where the power supply is applied, right? In the left side, you can see the back side of the stacks. This is the DV mode. So in the DV mode, you can see 4 feed streams. One is the feed, the other one is the concentrate, the other one is the electrorings, and the other one is the concentrate too. And for SV mode, we have 3 streams actually in the feed water: the electrorings, the concentrate, and the feed. In the SV mode, actually, considering the hardness is lower, so you don't need to have to remove this concentrate. So you just do like a loop here, and you have just one concentrate outlet. This is what FEDI stack looks like inside. We have 2 frames and anode and the concentrate compartment here. In between the compartments, we actually have a mat with the resins. This is one of our patents that I mentioned before. And we have very, how can I say, it's a very unique pattern here that helps in promoting more effective flow in the stack, rather than just pouring the resins inside. This allows us to have a better control of removal, and also improve the water quality in the end of the treatment. In terms of the mechanical design features, we have no O-rings. We have very special spacer designed to prevent leakage. We have central rib for additional strength, and all the components, our components are molded with which really confers higher mechanical strength. In terms of the operation, so this is the DV block diagram. In this FEDI DV, the feed water, as you know, flows from the bottom to the top. The first stage, you're gonna remove the bulk of ions, strong ionizable species as calcium, magnesium, chloride, and sulfate. with the low current and low pH. So we work with the current around 0.8 to 1.5 amps and the pH from 3.5 to 6. It can remove around 90% of the ionic loads. Then in the second chamber that we call the silica removal zone, we are going to apply a higher current, 2.5 to 3 amps and 9.5 to 10 pH. This is very simplified PNID FEDI 2DV system. This is for DV. You see 4 inlet connections here and 4 outlet connections. And this gives you an idea what are the main controls you should have in your plant, the pressure gauges, the flow meters, and the valves here. And this is for the single voltage module. So we are still removing the same species here, but at lower hardness level. So that's why we have only a single voltage and current running into the stacks. And we do not need to apply different currents in this case. For the PNID, very simplified here. Also, you can see 3 streams in the inlet, and there is no need to separate the concentrate in this case. So you have a loop from concentrate 1 to concentrate 2. The fatty HF, as I mentioned previously, this was the HF, it means high flow. It was especially developed for to increase the flow rate, and it's used basically after the double pass RO, where regular fatty has capacity of 15 GPM, the HF has capacity of almost 30 GPM. So the feed will be applied actually in the middle here. So that's why it's so different, let's say, because this feed water will be split in 2, and it's going to work like in parallel, right? This is the simplified PNID. You can see 4 streams for the inlet water, 1 for the concentrate 1, concentrate 2, electrorings, and for dilute water. And then we have 2 product lines here, actually, and 2 concentrate lines as well, because it's running in parallel. Okay, related power supply, I'd like to take a moment to put some comments here. One of the main components of the EDI is the DC rectifier. We have a software that, according to the feed water parameters, it helps us to specify the most suitable rectifier, case by case. Actually, the rectifier is used to control the voltage into the stack. And the QA does not manufacture the rectifier, but of course we can support you to select the best option for your application. In case of the dual voltage technology, you will need a rectifier that can handle both voltages. So those are the typical operating parameters. The main feed and product water specification you need to take into consideration here. One is FCE, and it's important to mention that the concept of FCE, because it takes into consideration the CO2 and silica as well. There is a formula for it. So FCE should be kept less than 40, pH 5 to 10, silica reactive silica less than 1 ppm, total hardness less than 3 we can handle, TOC less than 0.5, heavy metals less than 0.01, and free chlorine less than 0.05. The water SDI should be less than 1. And as a product, we can mention the resistivity from 5 to 18 mega ohms. And the silica can be handled with less than 5 ppbs. On the right side, you can see the different models, the wide range of products that we have. We can show you the FEDI 1 and 2, which can handle a high hardness tolerant. We have the HF and also the RX for pharma. Those are our data sheets that are available to download in our website. This one is specific for FEDI, SV, and DV. You have, all of the modules here with the flows, feed, product water specifications, and weight dimensions and operation conditions here. The same is available for HF and for RX, the pharmaceutical modules. I would like to invite you, if you wanna have more detailed information, to download the data sheet, or you can also ask me, I can send it to you. And this is the FEDI RX, some additional information about our RX developed for pharmaceutical applications. This really delivers high product water quality. In terms of the resistivity, we can go up to 16 mega ohms. It's very quick hot water sanitization. It happens, and we can handle up to 85 Celsius degrees. We have the triclover fittings according to the pharmaceutical requirements. And I can say that exhaustion and regeneration is not required before and after the hot sanitization. So it's a huge advantage here. We can quick high product water quality after the sanitization. So you don't lose much time after the sanitization, and this represents a very good operational advantage. This is compliant to FDA and CE certified. We have several case studies that we can share with you if needed. Related to cleaning, I'm gonna take this moment to just mention because a lot of customers ask about cleaning. So even though our stacks are designed to minimize the scaling and fouling, over a period of time, maybe the cleaning will be required. So the procedure is as simple as regular CIP. You can actually use the same CIP you have in your RO system. For acid cleaning, you need a solution of HCl and then sodium chloride preparated with RO, with the RO permeate, right? The important thing here is that you have to use high pure grade of chemicals. In our manual, you can find the detailed information and procedure for the cleaning, and also the specifications for those chemicals you should use. Oh, forgot to mention that the frequency, of course, is going to depend on the feed water parameters and the operational conditions also. But according to our previous experience, we can say that once or twice a year for most of the cases, unless the TMP increases drastically, you have to proceed the cleaning. Related sizing program. Qua have a very friendly use sizing program that you can also request to download on our website. I'm sure it's going to help a lot designing your projects here. This is pretty similar to RO sizing program, actually. It's very important tool because from then you can select the optimal model for your specific application. Automatically filters the models that are not suitable based on the feed water quality, flow, and product requirements. This prevents you to choose the wrong module that may not suit for your application, and automatically provides you with the maximum allowable flow per stack based on the feed water parameters. We can assure that you're using the minimum number of stacks, optimizing, of course, your project cost. The basic inputs usually are provided by the feed water analysis, or you can use the RO projection. The program asks for conductivity, flow rate, targets silica, chloride, sodium, and any other requirements, and also the product pressure. This is how the interface looks like. The parameters you need to inform here in the left side, the product flow and the specifications for the treated water. If you go to this arrow here, you can select the module, and it will also provide you with the main information per module. In this case, we are selecting the high flow, the HF. This is after double pass RO. So it gives you some information related to the module. This is the report generated. This will provide you with the information related design parameters, the feed analysis, your product requirements here, and also the calculated product quality here. You have an idea about the quality of the treated water. It will also give you some this schematic, then you can understand on the concentrate, feed, and rinse flows. Again, we make this program available on our website, but we can provide you with the training, or you can also ask our support with any projection you may need. We created also this guide that helps when choosing the best fit for each application according to the hardness level. So for example, here, when the feed hardness is less than 2 ppm, but greater than 1 ppm, so probably the best option is FEDI DV. In case you have, for example, less than 0.2 ppm of hardness, then all of the modules could fit, but probably the best option would be the HF. That will provide you with the maximum flow. This one takes into consideration the product requirements. So when you have stringent parameters, like, for example, silica less than 10 ppb, sodium less than 3 ppb, chloride less than 3 ppb, usually the best fit would be SV or DV. And of course, you always choose the highest capacity in order to minimize the number of stacks. So this is kind of a guidance that we can provide you with as well. And if you have any questions, strict product guarantees, you can always contact us, and we work together with you to ensure that you have the best selection. In terms of references, our global success, as I mentioned in the beginning, FEDI is a proven technology. Nowadays, we have hundreds of installations around the world. Those flags in orange you can see here represent some of our references per region. Several references throughout North America, Europe, and we have many references also in Asia. I'd like to take this moment to share with you some case studies. So Brazos Electric is a power plant in Texas, and it's one of our longest running reference. It was commissioned in 2010 and is still running very well after more than 12 years of operation. And an important fact here is that they replaced the modules just two years ago during an upgrade in the facility. It shows how robust is this technology with very huge lifespan. The FEDI water characteristics, they have silica up to 70 ppbs, and we deliver with less than 10 ppbs. And the inlet conductivity goes up to 7 microsiemens, and we deliver with 0.07 microsiemens. Here is a snapshot of 1 year performance comparing inlet and outlet silica. If you see, even during some peaks they had in August and September, FEDI was able to deliver consistent quality of the treated water, keeping the silica below 5 ppb during most of the time. There was some spikes in the conductivity also when you compare the conductivity over 1 year of performance. There was some spikes here, probably in the 49 and 65 days of operation. And even though regardless those spikes here, the product conductivity is consistently below 0.1. In many cases, below 0.05 microsiemens. So it shows the consistency of the product water in our FEDI stacks. Few other more references here. Sabine Pass actually is a LNG terminal in Louisiana. Is one of our largest installation, actually one of the largest EDI installation in the world. They have 9 trains of 465 GPMs, which means around 406 cubic meters per hour in total. Sorry. And we have total of 279 stacks here. It's one of the largest installation, as I mentioned. And some important information here is that this was installed after the first PESA RO. So our FEDI allowed them to save these CapEx cost, right? In terms of, we have also the South Coast Steam Power in Puerto Rico is another application, another plant. Actually here, we have 3 trains of 400 GPM, and we allowed the plant to be more environmentally compliant. In Atiko Refinery in Egypt, we have 2 trains of 465 GPM with 60 stacks in total. And it handles variable inlet conditions from a petrochemical complex. It's part of the ZLD solution. Zero liquid discharge. Petrogas Refinery in Turkmenistan. We have 462 GPM. In this case, you can see much less number of stacks. We have the HF FEDI. It provides high purity water with high flow for refinery boilers. In this case, they have limited footprint. So that's why they opt for HF FEDI. Anshan Steel is in China, is a steel manufacturing company. So they have 3 trains of 189 GPM, and it provides high purity water for a captive generation power plant as part of the steel production plant. The other one is TSA. Actually, we have a lot of references, mainly in India for pharmaceutical plants. And this TSA has multiple plants. And this is one of the references around 50 GPM. We have the FEDI RX 30X tax. It's a repeat client, actually. And as I mentioned previously, we have a new launch. We are very excited about this product. Actually, we are in the final stage of manufacturing. So the main advantage of Giga, actually, let me talk about the parameters here. We can take around 15 cubic meters per hour for each stack for the 45X. So we have much higher flow in compared with the regular EDI. This has also only 3 ports. So we have feed, product, and reject. So it's very comparable to the RO, much simpler operation and less instrumentation and piping required. So the main advantage of this product, I would say, it can take the highest flow rate with the minimum footprint, and it's coming soon. So that's all that I have for today. I'd like to take this moment to thank you everyone for attending as well, again, and open for the Q&A, the questions. I think I delayed a little bit, but we still have a few minutes.
Okay, so I will help with asking some of the Q&A questions. I'm Kamakshi and I'm in Adriana's team as well. If you can please put any questions into the chat or the Q&A section, we'll read them out. And alternately, if you're not able to do that, if you can raise your hand, then we can try to address your question. And any questions you might have that don't get addressed, we can send you an email or you can reach out to Adriana. Her contact details are right here. So the first question is from Guillermo. Guillermo. And the question is, for both concentrates, do we only use one flow meter? I think this is in reference to FEDI HF, if I'm not mistaken, Adriana. So if you can go back to that PNID.
Just a moment, please. FEDI HF. Yes, here we go. What's the question again? If there is only one concentrate here?
Yeah, so the question is, for both concentrates, do you use one flow meter on the outlet?
Yes,
and
yes.
I think in this case you do, but this is just a kind of a suggested, so you don't have to. You could use 2 separate concentrate flow meters if you really wanted, because I think there are 2 concentrate outlets for.
Yeah,
FEDI.
I think you don't need to use 2 flow meters because this is just to control your concentrate, right? So you use just one. And actually this concentrate, forgot to mention, but you can easily return to the RO. You have much, how can I say, it's very pure, actually, when we compare with the RO feed. So you just recycle to the RO system.
Okay.
Not sure if I answered.
Yeah, hopefully that answers the question, but in case there's a follow-up, please let us know and we can try to address it.
Yeah, of course.
Kamakshi, this is Abhijit here. I just want to intervene here. It could be probably this question also related to the DV also. DV stack where we have 2 concentrates, and that's where we'll need 2 separate flow meters.
Yes.
HF we can do with one flow meter, but DV will need 2 flow meters because these two concentrates outlets are different.
This one here, right? Yes.
Yeah, so if you see
Yes.
here, there's 2 different flow meters at the end, and the concentrate lines are separated for DV. So in S3 and HF operation, I think they can be only one concentrate flow meter, but in DV, it specifically has to be 2.
Mhm.
Okay. The next question is from Francisco. The question is, what are the contact details of the distributor in Mexico? Adriana, if you can advise.
Okay. Yeah, actually, we actually don't have right now distributor in Mexico. We have some partners that we work with. So if he wants to, I think we have the contact information, right? Of Francisco, correct?
Yeah.
Yeah, I can actually reach out to you, Francisco, and provide you with the information. Not sure if you're talking about only the modules or you're looking for the complete system. So we can discuss it later. I can share with you definitely some references that we could work together.
Okay, the next question is from Mauro. And the question is, are there any comparative studies of costs with mixed bed that have been done?
Yeah, there are some comparative studies. Actually, we are working on some updated version here because we have an old one, and I feel that we still need to update per region. Actually, these will depend on the region that we are working, of course. So they still, the components, the raw materials, the steel and everything can change in terms of the prices and cost. But I'm working on an updated version here. We have some idea that we can share, but I can also take the contact and work together to have this more, how can I say, define it later, because if you have some information about your costs, we can definitely go ahead and do the competitive study for your application in special. It
Yes,
depends
but I
also
can chip
the
in
flow
here.
rate. The flow rate and the capacity is gonna change, right? It's gonna depend on the capacity of the system. So maybe we could work in this specific case together. Sorry, Abhijit. You can add your comment, sorry.
I think Abhijit might be having issues with his sound. So, moving forward, we wanted to check if there were any other questions. I think some of the Q&A questions we did answer offline. So one was a question about hot water sanitization, the frequency of it. And that's expected to be every 3 to 6 months or as required by the specific plant.
Yes.
And then the other question was about having the presentation afterwards. That's something we can definitely share with you afterwards. So those were the other questions. Just wanted to make sure if there's any other questions, if anyone wanted to post in the chat. Otherwise, Adriana will put her details up on the slide so everyone can, reach out to her if there's anything that comes up after.
Kamakshi and Adriana, would you like to me to chip in on that answer for comparative cost between mixed bed and EDI, though?
Yeah, I think you have kind of a general idea from your previous evaluation, right, Abhijit?
Yes.
So I think
yes.
you can share
So,
in general, but I think to be more precise, I would suggest to work together and evaluate in the specific case of the customer.
yeah. Adriana, as she has said, these costs for the systems will vary from region to region, so it may not be little generic, we can give you an idea. But based on certain previous comparisons, what we have done, we have found that up to 25 meter cube per hour flows. It's a fully automated system of mixed bed, and the cost capex between mixed bed, fully automated system of mixed bed and EDI will come on the same. So you will start saving right from day one on the running cost for EDI. As the flow goes beyond 25 meter cube per hour, there are the capex of EDI will be slightly more. But when we talk of this capex, the extra money what you spent comes back. The payback period for this would be close to 2 to 3 years. And when we calculate these payback periods, we also calculate the cost of replacement of EDI after 5 years. So that means if you are considering a period of 10 years of operation with one replacement of EDI after 5 years, the payback period of extra money what you spent is 3 years. That means next 7 years what you will get free of cost operation. So that's the general idea. If the flows goes beyond 25 meter cube per hour, of course, the costs of the capex will vary from region to region because based on the system cost. I trust, but this will give you some idea of what these cost comparisons are.
Thanks, Abhijit.
So I don't think there's any more questions in the chat, so I think we can close it here. But of course, if you have any questions or want to reach out, Adriana's information is listed here, and you can definitely reach out to her anytime.
That's what I would say. So please do not hesitate to reach out if you have any questions, any doubts, any queries that we can support you with. And it was a pleasure to present a little bit about our technology. We have a lot actually to discuss related to technology. And if you would like to understand even more, please get in contact with us. Thank you so much.